You remember, we were discussing HTTP request format and HTTP response message. So while talking about HTTP request message, um, we said, in typical HTTP representation, which is HTTP 1.x, the request is sent in simple text, and the request looks like something similar to this, where first we have the header line, right? Then where we have first the method, which can be get, post, right, or head, or delete, okay, and then it would be followed by the path, right, and the uh, variant of HTTP, for example, HTTP 1.1, or maybe we are using HTTP uh, 2.0, or later we'll move to HTTP. We'll see HTTP 3.0, right? So then we have after this request line, then we have header lines. In header lines, we have a method and the value, right? So we have host, then its value, then user agent and its value, and the list is very long. Only some of the headers are methods are mentioned here, and then if it is a post message. So this can also contain some message here, right? That we want to post on our website. Okay. So again, as we have discussed earlier, that every protocol request response has a format, syntax, and semantics. So this shows the syntax where we first have the method. Uh, Here we have get. Then we have the URL, path, index.html, right? And then we have the version, for example, HTTP 1.1, and then the space and carriage, and then the line feed. Okay. Similarly, we have the header field, for example, post. Okay. And then we have the value, uh, the address of the website that we want to access to. Okay. And then similarly we can have other header field names and their values, and then so on and so forth. Okay, so this defines an HTTP request. And if I look at the different types of methods that are available, so we can post something on a specific as a part of the form to a specific website. We can get all the web objects from a URL. Then we can the head request is used for debugging here, right? Because it does not return any uh, web object, right? So we usually use this for debugging. Similarly, if I want to put some new objects on a link, I can use want to upload some new objects, I can make use of this put method. Okay, so once we are done with the HTTP request, obviously we'll receive a response. Similarly, response also has a syntax and semantics. So first of all, here we have header line, status line. Remember, in HTTP request, here we have the status line. So we have this variant first, and then we have the status, right? So there are different types of statuses available. In fact, the range of statuses that I'll talk about it in a minute, right? So HTTP variant is HTTP 1.1. Status code is 200, and status phrase is okay. 200 means that your request has been successfully entertained in this response. And then we have the header line. Okay, so in header line we have very important information. We have date first of all, then the server, right? Then last modified. This is very important field. We'll talk about this, right? We'll discuss web cache or proxy servers. When we talk about web cache or proxy servers, we'll talk about this header line, which is last modified or modified since, right? So again, then we have entity tag. This is also important with respect to our discussion on a web cache, a proxy server, right? So every object has an entity tag. We call it e tag, right? Then we have the range, except range bytes, the length, and content type, and there can be many other types of header lines as well. And then whatever the data, right? All the web objects, okay, will be uh, sent as a part of this request afterwards. After the talk about the HTTP response statuses. So there are different statuses, right? For example, 200. Maybe you have come across these, maybe, right? So 200 is okay, right? So 200 is the code, and okay is the request succeeded successfully. Okay, and then maybe we get this code in response. HTTP response, which is 301, means moved permanently. I mean, the requested object has moved to a new location, right? And then maybe we see this code 400, which indicates it's a bad request, right? It means the message was not understood by the server. And maybe we have this 404, means the web not found, right? The requested document is not found. Maybe you have come across this, right? This is very common. Okay. So then we have maybe 505, which indicates the HTTP version is not supported. So we have different range of these status codes. For example, um, if we have uh, stat- status codes from 100 to 100 to 199, um, used for telling some information. Okay, used for information. Similarly, codes from 200 to 299 uh, indicate success of different types. Okay, like 200 indicates that the request succeeded. Okay, then um, from 300 to 399, it indicates redirection. For example, look at this. 301 is telling us that it has moved permanently, right? So from 300 to 399, it indicates redirection. Okay, and from 400 to 499, it indicates client errors. For example, 400 is telling me it's a bad request, or the requested object is not found. Okay, so these are client errors. And similarly, from 500 to 599, uh, uh, these codes represent server errors. Okay, server errors. Okay, so for example, 505 tells that this version is not supported by the web server. Okay, so in the response we can have different codes, and then status phrase. Okay, or status description telling me what does it mean. Okay, so if it is 200, the page will be rendered and displayed on our screen. So you can try out yourself as well. I mean, on your Windows or Mac, you can write this netcat command to access your favorite uh, page, right? So you need to provide the name of the server, uh, okay, and then obviously the port, because HTTP request will be established on port 80, and then you can get the response as well. Okay. So when we started discussing about the HTTP, so we said, okay, HTTP by default fundamentally is stateless. Yes, no? Yes. So this means the client and server, two machines are not maintaining any state of the past messages. No inversion of multi-step exchange of HTTP messages to complete a web transaction. So we send one message and then we receive a response which contains the web objects. We process the web objects, or apply the style sheet, and then we display the page, right? But if we think of a you know, a stateful protocol, this means what can happen, right? So we have already briefly talked about this, but this means maybe the client is making some change. For example, there is a record, there is a file at server with the name X. So the client can ask to lock the record, X. So the lock is the record is locked, and then maybe the client has updated this, and the new record, which is X prime, right? X prime, right, has place in place of, or the previous record has been updated with X prime, okay, and it's logged, and maybe maybe client has made another request in, or made another excuse me, made another change in this file, and the new file is X prime prime, and is stored in this location, right? So okay, fine, but what during this what if during this process, um, a connection has disturbed, or connection has crashed, or a machine has crashed, right? So this will result into an inconsistent state either on the server or on the client, right? So this is the problem with the stateful protocol. So this means if it is stateless, this means what? This means no need for the client server to track state of multi step exchanges, right? Because it's stateless, all HTTP requests are independent of each other. As I was saying, that will send an HTTP request and it will receive a response and will just display the web objects, right? And we are done with our we're done providing the required function, right? But and obviously, then we don't want to the client or the server to recover from any sort of crash, right? To complete a transaction, a partially completed transaction. Okay, so so that we have already discussed, briefly, that HTTP by default is stateless, but uh, just to uh, just to make the interaction between the user and the server more, more customized, more personal, more, you know, uh, engaging, right? So we need to by somehow manage the user server interaction, right? Fundamentally, there is no such provision, right? So fundamentally, HTTP is stateless, okay? But if we want to, manage this interaction between the user and the server, or the client and the server, to make it more engaging, more customized, more, to give me more related response as per my preferences. There are four personalized. There are four components. If I want to, uh, you know, implement cookies, uh, I need at least four components. I need to add a header line, since we have looked at the HTTP request headers and HTTP response header lines, right? So we have to add a header line in the HTTP request. We need to add a header line in HTTP response, and then we need to maintain a file at the server, and we also need to maintain a file at the clients, right? So we need four components. Number one, we need to add, and we'll see in a minute, right? So we need to add what? So we need to add a, a cookie header line in HTTP response. So we'll see that there will be a new, header method, and header method name and its value. Okay, and then we need to similarly add a new header line, or we call it cookie header line, in the HTTP request. So one header line will be added into HTTP response, and one header line will be added into HTTP request. And then the host needs to maintain a file which is managed by the browser, okay, which is managed by your browser. Similarly, there has to be a backend database at the server managing the interaction of, or recording the preferences or the choices of the n number of requests coming from n number of clients. Okay, right. So let's assume that we have uh, an Amazon server, and then we have a client, right? So a client wants to go to Amazon server to browse some, to browse some options, buying options, right? So client will first of all send a usual HTTP request message, right, without any, um, you know, without any addition, right, without any header line to represent the cookies. Okay, so what the Amazon server does is it creates an ID for this user, right? So Amazon server, so this is component number one, right? Which is a file maintained at the client and managed by the client browser, And this is the component number two, which is a backend database, right, maintained by the web server. Okay, so whenever a new connection comes in, the server, in this case Amazon, assigns an ID, say 1678, to the user, right? And record this entry into the backend database. So this entry is recorded here. Okay, so it will record 1678 here. Okay, and now Amazon will send a response, but now this response contains the third component out of these four components, right? This is a usual HTTP response, but it also has a new header line, which is what? Set cookie. Right. So again, set cookie, just like user dash agent or uh, language type, is another field, and it's this value, right? So now the client will maintain what, um, a cookie and an entry against this web server. So for Amazon, we have this ID, okay, which is 1678. And similarly, this shows me that, okay, last time the client visited eBay, and eBay also signed it, and ID say 8734. Okay, so now let's say the client needs to browse something. I go to different to the book section to find the latest books on cookies and its challenges in terms of privacy and all that, right? So while I'm sending the request, browsing the different pages, I will always use this cookie header line, right? So, and the cookie header line for my interaction with the Amazon will always be 1678 for the moment, because the connection is still there. Okay, and I will browse through different options. So I will look at the books on cookies. I will look at the books on, for example, OSPF. I will look at the books on HTTP 2.0, 2.3, and all this is being recorded at the server, right? So cookie, my actions are being recorded, okay, so that I can get the cookie specific response later on. Okay, so where I'm going, what I'm browsing, right, against this, cookie is being recorded, noted at the backend database maintained by Amazon server. Okay, right. So I get usual HTTP responses, where the web objects are being displayed, showing me the books available on cookies and etc. Then let's say after 1 week I come again and I visit the same server Amazon, and I send a request, right? So this request will be a usual HTTP request plus what? Plus this cookie assigned by Amazon last time, right? And now, give in before sending me the response, the response will be cookie specific based on my past interactions, right? My past browsing history on books. So I will see certain ads or maybe preferences about the books on cookies and all that, right? So this is a usual HTTP response, but the web objects or the ads, right, or the information, right, or the recently purchased items will be related with my past action, right? So now this response is what? This response is cookie specific, right? So that this is, I feel, more personalized, right? Uh, in exploring Amazon.com, or for that matter, any other web server. Okay, so we need four components: header line, number one. Uh, we need a file which is maintained at the client by the browser. Then we need a backend database which is maintained by the server. Then we need HTTP header line in HTTP response, and header line in HTTP request. Okay, so cookies are very, very useful, right? Cookies can be used for a variety of purposes: for authorization, for shopping cart. For example, you remember, if you purchase different items, these items stay in your cart while you're browsing in between different pages, right? Okay, So it can make different recommendations based on my past experience, browsing history, and then user session state is also maintained. We'll talk about using web uh, uh, emails. Okay, so very very helpful in terms of recommendations, in terms of authorizations, in terms of maintaining our items in the cart, right? But the challenge is how to keep the state. I mean, so for that we need, this can be done at endpoints, right? These states are maintained by the sender and receiver over multiple transaction. Or how do we do this? By using the cookie, right? So at the server side, we have this cookie representing a client, yeah, right? And recording the different action, how much time you're spending on a different section of a web page, where you're browsing, and all this is being recorded by the the web server, right? And on the client, we just need to have one, the, we need to have one, maintain one cookie ID, okay? So, but the very important thing here that we need to discuss is the challenge associated with cookies, and the challenge associated with cookies is privacy. This is very important, right? Because look, how you browse over the internet, where you go, what are your interests, defines pretty much what a person you are, right? It defines the person. It defines your political choices, your religious, preferences or inclination. Okay, so when we allow a web page or a web server to track our interaction, or so this means cookies permit the sites to learn a lot about us, right, while visiting these sites. And especially when we talk about the different cookies, and we'll see in a minute, the third party persistent cookies keeps on tracking you know our browsing, okay, across the multiple websites. Okay, so and the cookies are pretty much can be considered, can identify us, right, who we are. So, so this means if this has a lot to do with the privacy of the data, and we need to be careful while allowing cookies uh, on our web server. Let me give you an example that how cookies work. Okay, so for example, um, I want to access NewYorkTimes.com. Okay, so this is my client machine. It sends an HTTP request message, right? So this is simple HTTP. This is usual HTTP request without any cookie header line. Okay, and I will get a reply from NYNewYorkTimes.com, right? But this NewYorkTimes.com contains an ad here. Okay, so here is an ad, and will not be displayed on my machine until this ad is fetched from another server. Okay, so the page is still not rendered and will not be displayed. So this is step number one, where I where I send this HTTP request, I mean a get message, typical usual HTTP request, and I receive this HTTP response from um New York Times. But this page contains an ad which needs to be fetched from some another server, for example edX.com. So now, as a request number three, or as a step number three, the machine will request, you know the machine will request, without, this is not in my knowledge, right? The machine will request what? Machine will request this edX.com for the ad, right? So this edX.com will in step five return the ad about this online business degree being offered by Purdue. Okay, now, the page is complete to be rendered and displayed on uh, my desktop, right, on my machine. Okay, so now the page will be processed, and in step number six, the page will be displayed on my machine, right? So this is the New York Times page with the embedded ad displayed, and this ad is fetched from edX.com. Okay. Now, now try to see this, how the cookies are maintained while doing the same task. So remember, the first will do what? Will send HTTP request message. This is step number one. And whenever a new request is received by a client from a client, so the server will maintain. Remember, the server is maintaining a backend database. The web server will make an entry in this backend server. Okay, so at the moment, let's say I'm exploring sports on New York Times, right? So I have accessed the sports page on NewYorkTimes.com to see the outcome of last night's UEFA Champions League matches. Okay. So now look at this. The New York Times is not only assigning a a cookie, but it also noting the browsing that on this date, for example, the 15th of Feb on 15th of Feb 22, I access sports. Okay, and will send me a response, and obviously will add this header, right, which is header line, which is a set cookie. Okay, so now remember, the client also needs to maintain a file at the uh, client machine managed by the browser. So we'll record this. Okay, fine. For our future interaction with New York Times, I'll be using this ID 1634. Okay, but now this page cannot be displayed, and we call it this first party cookies. By the way, cookies can be of different types. Okay, so cookies can be of different types. For example, we can have session cookies. Session cookies. Session cookies are very important. Used for login sessions, shopping carts, and stays in the RAM. Okay, so then we have persistent cookies. So this persistent cookie is on the hard disk, right? This is used to remember me. Remember, uh, you may have select this option, remember me. Okay, yes, no, visiting different sites or accessing this web pages. So, or to remember your language preferences, for instance, right? So, your language preferences, for example, say permanent, persistent. So, for this, we'll use persistent cookie. Okay. Then we have this first party cookie, which is an example. Uh, First party cookie. So, first party cookie is maintained. So, we are allowing the server that we are. Okay. So then we have secure cookies used for HTTP, especially when you're using for your banking login credentials, right? These are all maintained by HTTP, as in using what secure cookies, right? Then we have zombies. Zombies cookies maliciously tracks our activities. Okay, and then we have super cookies. So cookies are very aggressive in tracking our interaction, especially it tracks the entity tags that we have just looked at in the HTTP response. Okay, there are other types of cookies, but these are the most prominent ones. Okay, so the cookie that is maintained by um, the New York Times, the website that we choose to visit is known as first party cookies, right? So in HTTP reply, we receive this cookie and we record this entry into our local file. That okay, this is the cookie signed by New York Times. Okay, now remember, New York Times page cannot be displayed because it has an ad which needs to be fetched from another server, which is edX.com in this case, right? So now in HTTP request, there is a refer, right? That this request is being referred uh, by New York Times Sports, right? So look at this. The ADX will maintain uh, an entry. Okay, okay, fine. This this cookie is assigned to this client based on a referral from New York Times Sports on this date, right? And it will send the response by sending the ad and also the cookie, right? So the client will set a cookie for the third party, which is adx.com, 7493, and this is called third party cookie, right? This cookie is from the website we did not choose to visit. Okay, so my interaction is with New York Times. Okay, but I'm getting this response from a third party. This ad from the third party. So question, Abhisika? Any questions? Okay, so now how this third party is tracking our behavior? Let's try to observe this. So let's assume that then I visit another uh, web server, say socks.com. I make a request, say HTTP GET, which is usual HTTP GET. I receive, response. This response also has a cookie, right? And now, again, this socks.com page has the page I'm, trying to access from this socks.com has an ad which needs to be fetched from adx.com. Okay, then again, I will get in step four, I will send a request, and now the referral is socks.com. And because I have interacted with the adx.com, I have the cookie, so I'll use the same cookie. But look what this adx.com is doing, is recording my browsing um, uh, details. Yes, no. On this date, um, I visited New York Times sports page, and then later on the next day, I'm visiting socks.com. Okay, and maybe this will keep on going if I have to, uh, get ads from this adx.com. Okay, so now I will receive a reply. Okay, and then I'll display the web page. So adx.com here, which is the third party, uh, is tracking my interaction across the different web servers. Example, now I again, go to the next day I visit newyorktimes.com to another page, say arts, okay, section. So I send a request, I receive a response, and this is very interesting, right? And this again here, as a part of this display of this page, I need to get an ad. And now again I go to adx.com, and adx.com is recording my browsing, which is New York Times arts page on this date. Okay, and now when it returns the ad is specific for, and where we go, where we browse, what we see, what we explore defines our identity, right? It defines who we are on the internet, right? Yes, no? Yes. So that's why cookies are, just very important, in terms of making this interaction very, personalized and uh, useful. But on the other hand, there is a lot of concern as far as the privacy is concerned. Okay, so by default, in Firefox and Safari, the third-party cookies were disabled, right? And it was disabled in by in Chrome as well in 2023. But this is very important to read and to see what we did in this response to this. So this is EU's General Data Protection Regulations. We call it GDPR and the cookies. Let me read it. It's very, very important to understand this. So the natural person may be associated with online identifiers such as internet protocol addresses, cookie identifiers, or other identifiers. So what this says is that we are being identified by our IP addresses or by our cookies or other identifiers. This is who we are when we are present on the internet, right? So this may leave traces, which in particular, when combined with unique identifiers and other information received by the servers, may be used to create profiles of natural persons and identify them. Okay, So this pretty much, will define who we are. Okay? So that's why this is something very personal, right? So this creates the profiles of natural persons and identify them. Okay, and data is the key nowadays, right? So if we can create a profile of all the persons or the big chunk of people exploring internet, so we can make a lot of design decision making choices. Okay, and this happens in recent US elections and elsewhere as well. Okay, by profiling the people over the internet by means of their uh, you know browsing history, their interests, their religious, their political interests, right? So that's why when cookies can identify an individual, this is very important, right? So when cookies can identify an individual, cookies are considered personal data, subject to this GDPR personal data regulations. Okay, so that's why it needs to be asked, right? So that's why we, you know, we see this message a lot, right? This site uses cookies and give you control what you want to activate, which we blindly, uh, press this okay, accept all, where we have this choice as well, right? We can personalize as well that what we can allow and what we can block in this case, right? So after these regulations and concern over this privacy, we have this, this must request from web servers that the user can have explicit control over whether or not cookies are allowed. Okay, but nonetheless, cookies are very, very, integral, important, part of our internet browsing nowadays. Okay.